All right, so in this video, we're going to go over an in-class activity that you missed in class, which connects the concepts of factors, roots, and zeros of a polynomial. And this is a really good thing to go over, particularly at the end of the unit, just because it draws on so many connections. Well, the first thing we did is we talked about taking polynomials and writing them in factored form. Okay, so let's talk about what it looks like to be factors. So what I'm going to do here is I'm going to put up 3 problems, and I want you to independently write these polynomials in factored form. Okay, so there's your first one. The second one is x cubed minus 25x, and the third one is 3x squared plus 13x minus 10. Now this will also serve as a good review. So if you're comfortable here, I'm going to challenge you to hit the pause key. Factor each of these polynomials. Again, we're not solving for x, we're not finding the roots, I just want them written in factored form. And when you're ready to check your work, go ahead and hit the play key, and we'll go from there. All right, so what we're going to do first for number 1 is we're going to factor out a GCF. We're going to factor out x, and the remaining trinomial is x squared plus 2x minus 24. Okay, so then what we can do is we can factor this remaining trinomial, split the x squared, and I'm going to split the 24 into 6 and 4. And we see that if we make this a 6x and 4x, so if I could make this into a plus 6, take away 4, it will be factored. Okay, so that right there is factored form. We've been doing a lot with that so far in our unit. So again, here I can take out an x, and that leaves with x squared minus 25. So what I see is that we have the difference of 2 squares, so we can further factor x squared minus 25 into x plus 5 and x minus 5. And again, this is this difference of 2 squares where the plus minus is what makes the outer and the inner cancel, which is why we don't see this middle term. Now the last one I'm going to factor is going to be this trinomial, okay, with no GCF. So again, what we do is we split the first term into 3x and x, and we're going to factor the 10. I'm going to try 2 and 5, okay? So when I check my work, this inner is 2x, this outer is 15x, and it will make a positive 13 if we have a positive 15 and we take away 2. And so factored form is going to look like plus 15x for the outer and minus 2x. Okay, so that's just a good little review on first how we factor, but this is what it looks like to be in factored form. All right, so the next thing is let's talk about roots. So if I have this equation y equals x minus 1, you know what, I'm going to go back and number this here. We'll just call this number 4, okay? So for number 4, if we have this equation y equals x minus 1 and x plus 3, then the question's going to be, what are the roots? Well, the roots then, as you know, when something's in factored form, we then set the factors equal to 0, and the roots are 1 and negative 3, which means that visually this would be I know that this is a quadratic, right? So it's going to make a parabola, but it's a parabola with roots at 1 and negative 3, and it would be a parabola like this that crosses at those roots. Okay, so it would kind of go like that and be, sorry about that, I keep hitting the erasure key by mistake, and it would be this parabola. All right, well, what about something like this? Let's suppose we have a polynomial that looks like x plus 1, x minus 2, x minus 3. So again, this is the factored form. What would the roots be? Well, the roots are going to be x equals negative 1, and x equals 2, and x equals 3, right? So we can go back and forth over and over between finding a factor, okay, and finding the roots. And so if we were to graph this equation, it would have a root at negative 1, positive 2, and positive 3. And if you put this in your calculator, what you're going to see is this is a little cubic function here that's going to have these roots right there. All right, so finally, we put this all together, and what we learned how to do in class is how to write a polynomial equation. So how do we use this concept and go backwards and write polynomials? All right, so for let's make this number 6. Let's suppose the roots are x equals -3, 1, and 2. Okay, these are the roots. Well, what we could do is we can write the roots as factors. So if x equals -3, the factor would be x plus 3, just like we did over here in number 5. But this time, we're going from the roots to the factors. We're almost going backwards. Okay? Well, then we have x equals 1, which would be the factor x minus 1. And then finally, if x equals 2, the factor would be expressed as x minus 2. These are the factors. So what do we need to do to get this equation in standard form is we just multiply everything together. This, you can stay with me in the video, or if you want to pick up the pace a little bit, you could hit pause and let's practice multiplying this out. So what I'm going to start by doing is I'm going to double distribute these first two. So x times x is x squared. I get that the outer is going to be -x, the inner is 3x, and the last term is -3. Okay, and just keep bringing down that x minus 2. Let's combine like terms. So what I'm seeing right here is a -x and a 3x can combine to make plus 2x. All right, so one more step of multiplying, and we now have an equation in standard form. And so I'm going to multiply x squared times both of these. We get x cubed minus 2x squared. And then we're going to take 2x times both these terms. We're going to get plus 2x squared minus 4x. And then we're going to distribute the -3 and get -3x plus 6. So our final equation in standard form is x cubed. I notice here that -2x squared and 2x squared cancel. I see that these are going to combine like terms to make -7x, and the constant is -6. So what we learned how to do in class was if we are given the roots, how can we then write a polynomial equation? All right, we're going to try one more here. Okay, so suppose we have the roots, okay, are going to be x equals 0, x equals 4i, and x equals -4i. Okay, because as we learned, complex roots always occur in plus or minus pairs. So what we're going to do is we are going to write these roots as factors. Well, if the factor is x minus 0, then honestly, there's no point in even having a parenthesis. So what we do for that factor is we just express it as x. Well, the factor, if x equals 4i, it can be expressed as x minus 4i. And if x equals -4i, this can be expressed as x plus 4i. So we do it the same way we did before, right? We just write it as factors. Now comes the multiplication. What I want you to do first is multiply these two conjugates right here. And so x times x is x squared. The outer terms is going to be 4i times x, which looks a little funny, but just write it for now. We'll see what happens. The inner term right here, right, is going to be -4ix. And then be careful with this last part. We're taking a -4i times 4i, which is going to make -16i squared. And we need to recall that I squared is equal to -1. Okay, so let's simplify before we distribute this x. And what I see is that -4ix and +4ix cancel, and we end up with -16 times -1, which is going to make this x squared plus 16. Finally, we distribute that last factor x, and the result is x cubed plus 16x. And so again, we just wrote a polynomial in standard form given the roots. Okay, well that's what we did in class. Hopefully you got all of this. This should all be written into your notebook. Okay, and then from here, I'm going to link the test review so that you can get started, hopefully outside of class to make up for what you missed. All right, thank you, bye.